Hello, everybody. So this is the first video in a new set of videos about energy balance, which is part of the principles of chemical engineering course, which covers mass and energy balance. I found mass balance covered a lot in many videos and playlists on YouTube, so I decided to go directly to the energy balance, since there are other resources that you can find about energy balance, about mass balance. I'm sorry. So the textbook I'm using in this set of videos is going to be the Felder's Elementary Principles of Chemical Engineering, or chemical processes. Um, the part that we will be covering is starting chapter 7, so it's going to be chapter 7, 8, and 9, which are concerned with the energy balance. The first parts, or the first chapters, especially chapter number 4, is what is focusing on the mass balance. We might need to relate to some of these principles covered in the mass balance part, and in these cases I would be quickly reviewing the concepts that we want to remember, and we will need an energy balance. So what we're going to start with is chapter 7, which is talking about energy balance. But I like to give an introduction about energy balance first, and to give an idea why energy balance is important. So if we look at a flow sheet like the one that we see here, this is a flow sheet that, it's not very complex, but it contains many units, and the units that you see here, most of them are units. If you come with the background of mass balance without knowing a lot about energy balance, you would see that there are units that are understandable. So you know that this is a mixer, that this is a mixer, you know that this is a reactor, that these are separators. So there are things here that you know why we need these units, and what is the functions or what are the functions of these units, either separators or reactors or mixers or whatever. But in the same flow sheet you will find some units here that might be strange from the mass balance point of view. So for example, this unit, it has one stream in and one stream out. It's not a reactor. So the reactor, we understand that it might be one inlet and one outlet, and that there will be differences between inlet and outlet compositions and flow rates because of the reactions taking place. But in here, there is nothing changing, or there are no changes in the composition or the flow rates. The same here. And these two units are called heaters and coolers. So these don't do any change in the composition. So from the mass balance point of view, they are useless, or it's none of our concern when you do mass balance calculations. The function of these units is to change the temperature and pressure, mainly temperature and pressure. Sometimes it might change in the phase, but in general, this is what we need, or why we need these units. If you look at a real flow sheet, a bigger flow sheet, you will see that these units are a lot. You'll see, for example, here that we have all these are units that have one stream in and one stream out. This is one stream in, one stream out. All of these are just units with one inlet and one outlet. And as you see here, those with the letter E106, E103, all these with the letters are called preheaters. They are called heaters or reboilers. For this H, it's called the feed heater as well. So these are all heaters that change the temperature. This is it seems that these units are really important because we have a lot of them. You'll also notice that there are units here that have the same thing, that they have only one inlet stream, one outlet stream. This C is called the compressor. This P is called the pump. So the question is, why do we need these units if we're looking at this flow sheet from the mass balance, again from the mass balance point of view? These are all units that we will not consider when we do our calculations. And the flow sheet in case of mass balance is way more simplified than what we see here. So the functions of these units is, as I told you before, that we need them to change the temperature and the pressure. So the question is, why is it important for us to change the temperature and pressure? So this is a question that we need to answer. So the reason of or why these units are important is that all the units that we have, you see here in this flow sheet, whether this is a reactor, whether this is a distillation column, whether it's a flash unit, whatever the unit is, it's designed to be operating at specific conditions of temperature and pressure. This is something that we know from the thermodynamics, that we know from the reaction kinetics, that we know from the separation calculation of the separation units like distillation. So the temperature and pressure must be well adjusted so that the unit is operating efficiently. And if these conditions of temperature and pressure are not well adjusted, then the unit will not operate properly. Which means that the reaction will not take place as designed. That the separation will not be as designed. It means that the whole process is going to be messed up. So that's why we need to adjust these conditions of temperature and pressure, and that's why we need to make sure that we have some units that will take care of this adjustment. That we need to make sure that the temperature is well adjusted and the pressure is well adjusted. So the heaters, the coolers, the heat exchangers, and the furnaces, these are all units that we use to change the temperature. The pumps, the compressors, the valves are used to adjust the pressure. So again, from the mass balance point of view, these units are not changing anything about the flow rates, about the compositions. They are changing the other parameters of pressure and temperature. So this is what we said, that there are no change in composition. So the energy is what is changing. It's not the composition but the energy, and this energy is in the form of temperature and pressure. And it's very important to know how much energy you need to provide to the heater, or how much energy you need to provide to the pump, so you know how much money you are gonna pay. The energy is money, so you are putting money to operate things. So that's why we need to know how much energy we need to put for each one of these units, because this is part of the economic evaluation of the process. So to be able to do these calculations, we need to know how to do energy balance calculation. So this is what we are going to do in this part, or in this course, that we are going to talk about the energy balance calculation. So starting next time, we will start talking about the basics of energy balance, and what is the main concept that we build our calculations on, and how we can derive the equations of energy balance. So we'll continue next time, inshallah. Goodbye.